we're looking at our second shape. Last time we looked at triangles, and today we're going to look at rectangles. And so we'll go through a lot of the same things that we did with triangles. We'll look at the different properties that rectangles have. We'll look at how to find perimeter and area, and how to work some of those problems once variables start getting involved. So just in general, a rectangle, as hopefully you're aware, is a four-sided figure. It's got four sides. It's got two sets of parallel and congruent sides, and has four 90-degree angles in there. So there are some important properties of rectangles that you should be familiar with. Okay, the first is that the opposite sides of a rectangle are parallel and equal in length. And when you look at a diagram of a rectangle, the way we want to notate that information, let me go ahead and draw that on here, is that if they're parallel, you're going to see like little sort of angle marks. Let me show you what I mean by that. Something like this to show that this side is parallel to this side. And since a rectangle has two sets of parallel sides, you're going to see a similar symbol on the other pair of sides, but there'll be two little arrows instead of one, just so it's very clear like which set of sides are parallel with which. I mean, I think you can kind of tell just based on the picture, but just to make it 100% clear there. And then also the opposite sides have equal length. And so the way that we're going to notate sides that have the same length, and we use this with the triangles, and we went over like isosceles and equilateral triangles, but when you have side lengths of a geometric shape that are the same, you put a little dash on them. So I'll put a little dash on this one and this one to show that those two sides have the same length, and double dashes on the other side. It doesn't really matter which ones have one versus two, but whichever ones are congruent to each other need to have the same number of dashes. So for lines that are parallel, we're going to use the symbol like this, and then equal in length, we'll use just like a little dash to show like what that means. Another property that rectangles have is that each angle on the interior of the rectangle is a right angle. And so last time we talked about right triangles, which were triangles that had a right angle in them. All rectangles will have right angles. All the angles have to be 90 degrees in order for it to be a rectangle in the first place. So the way that we'll see that notated is that on these angle measures, there'll be like a little square in the corner. So like it'll look something like this. And it's going to be true for all four of these angle measures. They're all 90 degrees. And since they're all 90 degrees, they're all going to add up to 360 degrees. So a triangle, the sum of all the interior angles of a triangle add up to 180. But for a rectangle, they all add up to 360. Because you have a 90 degrees, right, times four angles is 360 degrees. All right. So if I give you, I mean, they're all going to be 90, so I probably wouldn't ask you about the angle measures individually because they're just always going to be 90 degrees, so there's nothing to really solve for, but it's still good to know that. Next, the diagonals. So the diagonals of a rectangle are going to be line segments that connect opposite vertices. So like the two corners that are opposite of each other. So like if I draw a rectangle here, one diagonal would go from this vertex to this vertex. So that's a diagonal. And then a rectangle will actually have two diagonals. That's one of them. The other one goes from here to here. So those are diagonals. And what's true about the diagonals of a rectangle is, number one, they bisect each other. And by bisect each other, what I mean by that is that they sort of cut each other in half so that this side length is equal to this, right? Or not that side length, but that line segment from the vertex to the center is the same length as the center to any other vertex. So yeah, the diagonals, they bisect each other, but additionally, the diagonals have the same length. So all four of these little line segments inside here have the same length. Right? They cut each other in half, and they're all equal. Any questions about any of those properties so far? All right, let's talk about the perimeter of a rectangle. So just like with a triangle and really just any figure, the perimeter of a figure is the sum of all the side lengths around that figure. So we can simplify that for a rectangle since we've got four sides here. One way to think about it is, just the two lengths plus the two widths. Right? Sometimes you'll see it written like that. Sometimes you'll see it written like 2L plus 2W. And you might also see it written, as it's stated up there, 2 times the sum of L plus W. All three of those equations are equivalent. I don't really want you to memorize an equation for this. I'd much rather you just understand how to find perimeter in general, which is just to add up all the sides. So one of the TSIA2 math problems that you might come across is going to be kind of like this next example where it says a rectangular swimming pool is X meters wide. So that's one of the dimensions, X. So maybe I'm going to sketch out this rectangle. So the width is X. And it says the length of the swimming pool is 3 times as long as the width. 3 times as long as the width. So the length would be 3x. All right, so just to kind of break that down, the width is x and the length is 3x. It says if the perimeter of the pool is 32 meters, find the dimensions of the pool. So to find the perimeter, you add up all the sides, and it says for this particular pool, the perimeter is 32. So if the perimeter is twice the sum of the length and the width, or you could use any of those other formulas, or you could just add them up. Any way you want to do that is fine. I'm going to rewrite this as 2 times the length, which is 3x, plus the width, which is x. It also says that the perimeter is 32, so I'm going to replace that p with a 32. And what we can do with this equation now is solve for x. Now the question's actually asking for both dimensions. So x is the width. That's going to give us one of the dimensions, but we'll still have to go back and calculate the length once we have the width, although it shouldn't be too hard because the length is just 3 times the width. So to solve this equation, first we'll distribute the 2. We'll use the distributive property here to get 32 equals 6x plus 2x. You could have also combined the like terms, 3x plus x equals 4x, and then multiply afterward. Either way is fine. 6x plus 2x is 8x, so we have 32 equals 8x. And then to isolate that x, we need to divide both sides by 8. So 32 divided by 8 is 4. So we get x equals 4. Now, if it was just asking for the width or just asking for x, that would be our answer. But the question here is asking for both dimensions. So the width, which is just x, is 4 meters. And then the length, which is 3 times the width, would be 12 meters. Another perimeter problem down here has to do with the perimeter of a square. Now, one thing that's true about squares is that they are in fact rectangles. They meet the classification for a rectangle, but a square has one added characteristic that just a generic rectangle may or may not have, and that is on a square, all side lengths are the same. So every square is a rectangle, but not every rectangle is a square. Squares are a subset of rectangles. And so when we go to find the perimeter of a square, it's usually a little bit easier than doing that with the rectangle because since all the side lengths are the same, if we call the side length s, then we have s plus s plus s plus s, or x, or whatever variable you want to use. That equals the perimeter. And since we're just adding 4 of those exact same sides, we can also just write that as 4 times s, right? So the perimeter for a square is a little bit easier to calculate. Yeah, I think if you think about it more generically, where it's just the sum of all the sides of any figure, you don't have to memorize these formulas separately. You just have to know like what perimeter means. So down below, we've got another example. It says the perimeter of a square shown below is 44 units. What is the value of x? So if the perimeter of a square is 44, and we know that we can multiply the side length by 4, because there's 4 sides, they're all the same, to get that perimeter, we can set up an equation that looks like this. 44 being the perimeter equals 4 times the side length, which is x, and then divide both sides by 4. So divide by 4, divide by 4, and so we get x equals 11. So that means that the side length of this square is 11. And all the sides are the same, so you don't have to find them separately or anything like that. Any questions about perimeter? Okay, well, let's talk a little bit about area of a rectangle. Now, the formula for area of a rectangle is actually a little simpler than the formula for area of a triangle. With a triangle, it was half base times the width, so you just take the 2 dimensions that were perpendicular, multiply them together, divide by 2. With a rectangle, you don't have to do the divide by 2. And I think you can kind of see why you would divide by 2 for a rectangle, for a triangle. Because if I take that rectangle and I just draw one of the diagonals like this, that's going to cut it into 2 triangles. So the area of the triangle should be half the area of the rectangle. So the rectangle is just base times height, or length times width, whereas the triangle is half that. So I just want you to see that connection there on why the formula for a triangle is half base times height instead of just, multiply the 2 sides together. So let's say we've got a rectangle. We've got the area formula. It says if the length of a rectangle K, or is K, so the length is K. Maybe I'll just write that out. The length is K. The width is 4 more than the length. So 4 more than the length would be K plus 4. It says, what is the area of the rectangle in terms of K? Well, if the area is the product of the length and the width, so I'm just going to write like L times W to kind of just start it off, and the length is K, and the width is K plus 4, we can simplify this expression by using the distributive property. So distributing that K, we get K times K, which is K squared. And then we also have K times 4, which is 4K. And so this would be our expression for the area. It's not asking us to solve for K or anything. We really couldn't anyway because we don't know what the area is. But it's just asking us to come up with an expression in terms of K for the area. But really, at the end of the day, you just multiply the 2 dimensions by each other to get that area. A couple of more square problems down here. I just really one here. But just like with the perimeter, this kind of goes over what a square is in relation to a rectangle. Again, it just is a rectangle, but it's sort of a special rectangle where all the side lengths are congruent. So if we want to find the area here, you can think of the area as length times width, which in this case would be S times S, if the side length was S. And then anytime you multiply something by itself, that's the same thing as squaring it. So if you have a square, you can simplify that formula for the area. It's just the side times itself. You just square the side length to get the area of a square. That's actually why we call it squaring. Yeah. So when you square a number, what you're really doing is finding the area of a square that has that as its side length. Just like if you cube a number, you are finding the volume of a cube with that as its side length. And we're not really getting into volume today. We'll do that later in the unit, but that's why we use those words. So the example problem says the area of a square shown below is 49 square units. What is the value for x? So here we want to set up an equation for the area, which is x squared, and that equals 49. And so to solve an equation where you've got a number squared equals some other number, to get rid of that squaring, we need to take the square root of both sides. So we have the square root of x squared equals the square root of 49. The square root of x squared will just be x, and that is why we're taking the square root of both sides, to get rid of that squared and just be left with x. And the square root of 49 is 7. And you don't necessarily need to know that. I mean, you might just know that, but just based on experience. But if not, you can always put that in your calculator too. Any questions about perimeter or area or anything involving rectangles so far? All right, so let's take a look at just a couple more advanced problems here. These are going to be just a little bit harder than just kind of basic perimeter and area problems. This first one says the length of a rectangle is 10 inches greater than the width. So the length is 10 inches greater than the width. So just right away, I'm going to write an equation for that. And I'll call the length L and the width W, just to make it easy to see, kind of keep track of where everything is. So the length is 10 inches greater than the width. So the width plus 10. It says if the perimeter of the rectangle is 36 inches, what is the length in inches? So the length is 10 more than the width. Perimeter is all the side lengths added up, right? It's 2 lengths plus the 2 W's, which we can simplify as 2 lengths plus 2W. And you can also write this as just 2 times L plus W. All three of these equations are the same. So you can kind of take your pick on which one you like best. But for whichever one you pick, we're looking to solve for the length. Now we have the length in terms of the width, but what we really need is the width in terms of the length, so that we can solve this perimeter problem for the length. So first, I'm going to rewrite this equation for length so that it's for width in terms of the length. And all I mean by that is we're just going to subtract 10 from both sides of this equation and get L minus 10 equals W. And the reason we're doing that is because we want to solve the perimeter equation for the length. So we want to essentially get rid of the width in that equation. The width here is L minus 10. So I'm going to take that expression and substitute that in for the width. Basically, instead of writing W there, I'm going to write L minus 10. The perimeter of the rectangle is 36 inches. So I'm also going to make that substitution. The perimeter of the rectangle is 36 inches, so I'm going to replace that P with 36. And I'll just go with this last version of the equation, but you can pick any one of those. So 36 equals 2 times L plus L minus 10. And I'm writing those things in blue just to show you what's changing from the previous step. Now we've got an equation that has just L as a variable. So now we can solve for the length. So I'm just going to simplify what's inside those parentheses first. L plus L is 2L. So 2L minus 10 inside there. Then I can use the distributive property and multiply 2 by both 2L and negative 10 to get 36 equals 4L minus 20. And now we've turned this into a two-step linear equation. You guys have been pretty good about solving these kinds of equations in the past, so I won't drone on too much here. You just want to add 20 to both sides, and then we're going to divide by 4 after that. So 56 equals 4L, and we'll divide both sides by 4. I'm kind of running out of room here. That's okay. 56 divided by 4, and I would use a calculator here. Don't bother trying to do that by hand. The length is 14. So this one's a little bit more advanced than some of the other ones we've done so far, but I think you still should be able to handle this one. Any questions about what we did on this problem? All right, the last kind of problem, and we saw one like this when we were preparing for the TSI that first time. You might recall that bathroom problem where you're trying to tile the bathroom, but you don't want to tile underneath the tub. So you have to find the area of the room minus the area of the tub. That is really an example of what I like to call the picture frame problem, where you try to find the area of some shape with some shape like missing, like taken out of there. So like in this case, you've got like, we just want the area of that shaded region. So we've got a rectangle with a rectangle missing. And so the overall strategy for finding this shaded region is to take the area of the big shape and find basically all of this area, including what's missing. So find like this total area, and we know how to find the area of a rectangle, just base times height. And then we're going to remove the piece that we don't want, which would be all of this area in here. All right, we're going to get rid of this piece. So just sort of strategically here, we want to find the area of the big shape minus the area of the small shape. This looks a little messy, so I'm going to erase all that. Okay, so the area of the big rectangle is 4 by 5. So we've got 5 times 4 minus the area of the smaller rectangle, which is 2 by 3. And then we can compute it. So 5 times 4 is 20. 2 times 3 is 6. 20 minus 6 is 14. So the area that's shaded is 14 square centimeters. Now this next question is a little bit of a throwback to when we, I guess it was Unit 2 when we talked about percents, or was that Unit? No, yeah, I think that was Unit 2. It says, what percentage of the large rectangle has been cut out? So to calculate a percentage, you want to find how much of the overall shape have you removed there. So the area that we removed was this area in here, right? 3 by 2, that's 6 square centimeters. So the large rectangle had an area of 20 square centimeters. We found that in the previous problem. The smaller rectangle has an area of 6 square centimeters. You can subtract those to find how much is left, which is what we already did, but this is asking specifically about the percentage. So for the percent, we are interested in how much has been cut out. So that will be the piece we cut out, the 6, out of the total area, which would be 20. So this is something that you can throw into the calculator. Actually, this one would be 3/10, so that would just be 0.3. We want to write it as a percent, though. So if we have 3/10, that's the same thing as 30%. So that's about it for today. I don't think there's any real, yeah, that's about all.